Good afternoon, everyone. How are you all doing? How are you holding up for the third day of the event? All right. My name is Sunil Gudur Valmiki. I'm a Vice President of Product Management in Data Center Networking team. And I'm super excited to co-present this session on AI networking with Rakesh Chopra. He's sitting right there, our SVP and Cisco fellow from Common Hardware Group. I and Rakesh will give you next level of details on all the innovations that we announced in the keynote yesterday with regards to AI data center or AI-ready data center. Okay? I'm also super thrilled to share that we have a customer who has gone through a profound AI success story, CVS Health, towards the end of the session. So Lenny from CVS Health, where is Lenny? Yeah. Lenny from CVS Health will come on stage after me and Rakesh. So with that, let's get started. Hopefully it works. OK, there you go. Whether it's AI or center stage presentations, they are always measured in time. So AI performance is measured in time. Time to first token, time to remediation, and ultimately, time to value. Time is the new currency. AI can run as fast as the underlying network. So AI network forms the foundation for AI infrastructure, right? But the AI workloads, AI applications, are different from traditional workloads in three different ways. First and foremost, AI applications are massive data engines. They generate and consume so much data, and they are pushing even the existing 800 gig infrastructure to their limits. The second one is AI applications are very power intensive. There's an estimation that in 2026, data centers will consume double the power because of AI. So the infrastructure must give more performance per watt. The third one is AI applications, unlike traditional applications, they're very sensitive to any network issues, whether it's congestion, latency, packet drops. All of these issues can slow down or halt AI applications. And this would leave GPUs idle, and then that is not the outcome that you want. How can we get AI applications run faster? How can we get you to your AI goals faster? It comes down to two things: scale and simplicity. Scale keeps the data flowing, the GPUs stay productive, and AI jobs are completing faster. Simplicity ensures that these complex AI environments can be managed, operated reliably. Issues are recognized, identified, and resolved before the performance degrades. Okay? Now, this requires us to deliver these innovations across the entire solution stack. When I say solution stack, it starts from silicon to systems to software, optics, and also not forget the operating model. We, Cisco, are the only vendor who can deliver on a fully integrated stack. And in the keynote, we announced innovations across all these foundational building blocks. Right? With our rich portfolio, we are able to address the unique requirements for pretty much all of our customer base, whether it's hyperscalers, whether it's neoclouds, sovereign clouds, service providers, and enterprises. Now, I would like to invite Rakesh on stage to walk you through the innovations that we announced yesterday on silicon systems and optics. Rakesh, please come on.
Thank you, Sunil. So that's going to be a tough act to follow, so I'll do my best here. So as Sunil mentioned, if we think about AI infrastructure, it is a daunting task to build and operationalize artificial intelligence clusters. And you need an end-to-end solution to actually do that. And Cisco is completely uniquely positioned to enable that, much like Sunil sort of talked about. But at the end of the day, the right way to do it is to think about that layered stack that Sunil just showed. And let's start at the bottom of that foundation. Cisco Silicon is the foundation of AI. So this week at Cisco Live EMEA, we announced several things. The first thing we announced is our G300. It's a 102.4 terabit piece of switching silicon with 64 ports of 1.6 terabit Ethernet. And this is powered by our Cisco Silicon One architecture. We also announced two different types of optics, a 1.6 terabits per second OSFP optics and an 800 gig LPO-based optics also in the OSFP form factors. And these are actually powered by Cisco Silicon Photonics. So what you're seeing is an end-to-end investment portfolio behind Cisco, driving Cisco's investments in silicon to enable that stack on up. But if you think about the number of companies that are actually capable of building a 100 terabit class piece of silicon, that's a pretty elite group of people, right? There's not too many people out there. But the way we're doing it here at Cisco is fundamentally different than everyone else in the industry. Everyone else is focused on just speeds and feeds, which is critically important, of course, but it's actually not enough when you think about the challenges of an AI computer. What we do here at Cisco is we focus on efficiency, programmability, to drive down the total cost of ownership of your AI infrastructure. And we do that by focusing on two main areas in the Cisco Silicon One G300. The first is what we call intelligent collective networking. This is actually a group of three separate functions that work together to drive efficient AI infrastructure. The first one of that three is actually our packet buffer. So we not only have the largest packet buffer in the industry, but it's fully unified across the entire device, and that guarantees that traffic flows seamlessly through the network, regardless of bursts or strange traffic profiles that may exist in AI workloads. The second is we've embedded intelligent hardware engines inside of the G300 to load balance traffic. And what these do is these work collectively across all G300s in the network to create a map of all of the traffic flows, congestion points, and failures in the network to enable an autonomous decision of how to optimally deliver your traffic to the endpoints. The second, or the third piece of that is we've actually embedded into the silicon hardware-based telemetry engines. And what these do is these monitor in real time exactly what is happening inside of the chip, and then advertising that functionality and its monitoring points to all other switches in the network, to the NICs, and to the orchestration layers above it. And that is critical when you think about delivering performance, but also enabling an orchestration layer to run on top and seamlessly manage your network. So what does this all mean at the end of the day? If we take it and we measure ourselves against various benchmarks in the industry, we're able to actually achieve 33% higher link utilization by using the technology in G300. So what does that mean? It means for the same network infrastructure that you build, you can populate more GPUs, dramatically lowering your total cost of ownership. The second way to look at that is actually if you measure job completion time, or JCT. This is how long a workload takes to complete on your GPU infrastructure. If you build your network with G300, you can lower that number by 28%, even compared to advanced packet spray technologies. That means your workloads finish sooner, which means that you can run more workloads in the same period of time, maximizing your investment. The next piece of the puzzle is actually what we call future-proofed infrastructure. And this, at its core, is based on our P4 programmable engine, which allows you to dynamically update the capabilities of the device in the field. So that plays out in a few different ways. The first is that you can actually load on new personalities onto your hardware infrastructure to deploy it in multiple roles, whether that's front end, back end, or spine. That allows our customers to qualify one system and deploying it everywhere, simplifying their qualification times and simplifying their support cost infrastructure to manage all of this network. The second way to think about that programmability is you can actually add new features over time. So what does that really mean at the end of the day? It means a few different things. One, your network is always up to date when new features are needed. But as we move from a notion that there's only a single job running on an AI infrastructure, and we think about agentic AIs, where you have multiple clusters communicating together, you might have a scenario where you want a cluster built with the previous generation switching technology to seamlessly communicate with the next generation technology. And to do that, you need programmability as well. Now, the most amazing thing about all of this is that we can give you all of this without compromising on performance. As you scale and add features to this infrastructure, we still maintain exceptional latency and power efficiency. Now, it's all good to talk about this in theory, but it's much better to actually sort of talk about how this has really played out in the past as real-world customer proof points. So if we look at our previous generation device, the G200 device, that was a 51.2 terabit device, and that is deployed across a huge range of customers, from enterprises to hyperscalers, across different sort of network roles, and that is all based on the fact that we have programmable infrastructure. If we think about features that we've added over time to support our customers, the list is huge, but in the interest of time, I'm only going to focus on a couple of them. The first one that comes to mind is that we were able to add support for the Ultra Ethernet Consortium, or UEC, to our 51.2 terabit device. This standard didn't even exist when we built that device. Programmability allowed our customers to deploy that once the standards got ratified on their already deployed network. The second is we were able to actually improve load balancing technologies by merging dynamic load balancing and a weighting effect to be able to sort of manage failures of the network. And finally, we've been able to add CSIG, a very advanced telemetry protocol, on top of this infrastructure. So I think the key thing here to understand is that with Cisco Silicon One, adopting new feature requirements is just a software update. It is not a rip and replace of your infrastructure like others. And we're not getting a new slide here, I think, but there we go. Okay, so now that we have the layer of silicon in place, let's talk about building hardware systems on top of that. In the second half of 26, we'll be introducing systems under the Cisco N9300 series, as well as the Cisco 81 series systems. So the first system we're here to talk about is a 3U air-cooled system with 64 ports of 1.6 terabits, built on G300. That'll support NXOS as well as Sonic. But we're realizing that different customers have different facility needs. So we're also producing under the same Cisco N9600 and Cisco 8100 series families, a fully liquid-cooled system. There are no fans in the system. All heat is removed in liquid, and this is designed for an ORv3-based infrastructure. So whoever you are from a customer perspective, whether you're trying to deploy 100 terabit systems in your existing facilities, or you're building brand new AI-optimized facilities, Cisco has a solution for you. Now, as we think about driving efficiency, because as Sunil mentioned, at the end of the day, it's all about power, okay? And to deploy 100 terabits of GPU capabilities, it took a minimum of 6 51.2 terabit air-cooled systems to build that network, okay? This was in the previous generation. As we talk about what we're announcing today, that collapses to a single G300-based liquid-cooled system, 6 systems to 1 system, significantly simplifying your deployment scenarios and driving an astounding 70% improvement in power efficiency. Okay? This is just with one generation of technology improvement. We are moving at an incredible pace here in Cisco. Now, we talked before about programmability and how that matters in the G300 and what our customers did with that in our previous generation G200. Let's take another example to understand the power and capabilities that it enables. Just 6 months ago at OCP, we announced the Cisco 8223 routing system that was purpose-built for hyperscale and neocloud scale across networks. This was built based on our P200 system, and that was running Sonic. Today, what we're announcing is a massive expansion of this portfolio on what P200 can do. First is we're adding a new system, the Cisco N9600 8100 series, which complements the previous Cisco 8100 series and a 51.2 terabit fixed form factor. We're also adding 28.8 terabit modular line cards within the Cisco 8800 and the N90 800 modular systems. So what have we done here? Because of programmability, we've been able to add a huge amount of features to this infrastructure. Okay, we're able to support NXOS, we're able to support ACI, we're able to support Sonic, we're able to support iOS XR. Okay, and now we're deploying this infrastructure across a huge portfolio: scale across, DCI, universal spine, core routing, and peer routing across a huge customer base. This right here is programmability in action. Now, if we think about what we were talking about before, at the end of the day, you have to have a foundational silicon layer. And for us here at Cisco, that is Cisco Silicon One. We have 5 families of silicon, which cover a huge range of networks, deployment topologies, and it provides you a unified, secure, and scalable infrastructure. But the programmability and the visibility that we put inside of Silicon One allows us to layer a software and network orchestration layer on top. So now that we have the hardware foundations layer, I'm going to pass it back off to talk about the amazing full stack solutions that we have.
Thank you, Rakesh. Thank you. That was a very good overview of what we announced in terms of silicon systems and optics at Cisco Live. Now, how does it all come together? How does it all work together and offer that simplicity that I talked about in terms of operations? That's where Nexus One comes in and delivers what you need. Nexus One is a unified and integrated solution stack that offers open choices at each layer in this solution stack. Nexus One provides that operational consistency regardless of the type of fabrics that you're operating. It could be front-end fabrics, it could be back-end fabrics, it could be storage, and it could be even out-of-band fabrics. Nexus One converges the existing operating system choices, whether it's ACI or NXOS and Sonic, and in future Hyperfabric, onto a common Nexus 9000 hardware or N9000 hardware. This year, actually last year, we announced Nexus Hyperfabric, and this year, what we are doing is we are onboarding N9K hardware into Hyperfabric, but also we are adding additional deployments into Hyperfabric, like multi-site. And also, very soon, we will launch the European cloud version of the Hyperfabric for our European customers. So that way, we bring Hyperfabric also into the Nexus One umbrella. The key thing that I want to point out here is that the customers can freely move between these different operating systems. And they can freely move between these operating models without having to go through any technical difficulty or even business friction. You're not locked in. Your hardware investment is protected with Nexus One operating model overall. As customers adopt AI, and Rakesh talked about scaling out and scaling across and all of these things, and so you will have to create massive scale out clusters and also scale across clusters. You will be creating different types of AI fabrics in different geographical locations in a very highly distributed fashion, right? And sometimes you could be extending even existing fabrics. You could be creating using NXOS or ACI or even Hyperfabric. Nexus One brings this uniformity and consistency in terms of operations. All these fabrics are interworking with each other and interoperating with each other using open standard protocols. That's what Nexus One brings. Nexus One provides easy-to-use Cisco-validated blueprints to create and deploy AI fabrics. So you will not have to actually know the configuration. We have done that heavy lifting for you with the templates in Nexus One. Also, Nexus One provides this comprehensive and deep visibility into the entire AI stack. And in this case, I would like to explain with an example. As you can see, AI job observability, right? And this is where we bring network visibility and compute visibility into a single layer and then provide that AI job awareness. And all of this is possible because of the telemetry that we can directly grab from the ASICs that Rakesh talked about. And with this telemetry, it's not just about the basics of interface counters, port counters. It is about we can spot those microbursts. We can spot those packet drops, congestion, latency, all of that before the AI job gets impacted, before the user feels the impact. So you can track the job health of a particular training job through the entire AI infrastructure, and then you can pinpoint exactly where the problem is in case if there is any issue. And again, let me show with another example. And there is that particular compute having an issue, and then the Nexus 1 capabilities will actually be able to point out, in this case, OK, there is a transceiver overheating. What is the impact? You will see CRC errors. And what is the recommendation? Replace it or check cooling. So it goes into like much more deeper level than what it is done today. Okay? We are making this observability even more intelligent and even more faster by bringing Splunk natively inside the Nexus dashboard. So Splunk instance that is sitting inside the Nexus dashboard, now it can receive this telemetry much quicker. And also, it can be part of Splunk data fabric that Splunk federated search can take advantage of without exporting the data into a centralized Splunk instance, right? And this is helpful in two ways. One is it helps avoid the duplication of the data, and also it helps with data sovereignty. It doesn't have to go everything to a single place, right? And it speeds up mean time to remediation and cuts operational costs. That's the advantage of native Splunk. OK, we talked about AI infrastructure so far, but let's change gears and talk about how we leverage AI to help supercharge the network operations for AI networks and also for non-AI networks, right? And this will be with AgenticOps with AI Canvas. We launched AI Canvas last year, and we started with Thousand Eyes and Meraki. This year, we are expanding the AgenticOps to data center networking, right? And again, this is about using AI to operate the AI infrastructure and also to operate non-AI infrastructure. So I would like to emphasize that AI Canvas is not yet another management tool, not yet dashboard or a simple chatbot. It is actually a command center for AgenticOps. It is a live system that is dynamically generated by the AI agents based on the problem that you're dealing with, right? So foundation of this AgenticOps is our deep network model. And this is more accurate, or at least 20% more accurate in those general purpose LLMs when it comes to networking tasks. And AI Canvas can troubleshoot your entire infrastructure by leveraging MCP agent integrations and using a simple natural language interface. So this is how we can use AI to make AI better. Okay? To summarize everything I covered so far, these innovations in all these foundational building blocks is about helping organizations to get to their AI journeys faster. Now let's see how one of our customers, CVS Health, are innovating and pushing the boundaries to supercharge their business. So let's roll a video first, and then Lenny will come on stage.
The network is playing a far more important role than it's ever played before. If the business comes to you and asks for it, I'm already behind. Staying ahead of those curves is paramount to our success. AI is leaking into the traditional enterprise applications that have always been critical. Nexus Dashboard allows for consistent deployment at the push of a button. The first system and the 100 system is designed exactly the same.
From Cisco perspective, we've got the high-power compute, we've got the network transport, we've got the software that helps telemetry the environment, so everything kind of comes together really well.
Cisco does a great job of continuing to innovate these systems so that they tightly integrate. Quite simply put, it gives you an end-to-end visibility in a single place. As CVS dives deeper and deeper into AI workloads, you can interact a lot faster. It brings the doctors closer to their patients.
All right, that was an amazing video. And here we are with Lenny, directly on stage to talk about his AI journey. Lenny, please join us.
Thank you.
All right, Lenny, to start with, can you please tell us about yourself and about your team?
Sure. First off, let me thank you by inviting us to Cisco Live EMA and giving us an opportunity to tell my story.
Thank you.
My organization, I lead network engineering and design for for CVS Health. And my organization basically supports network architecture, engineering, design, and implementation across our entire business, across the US. And that's basically 9,000 retail stores, pharmacies, prescription benefit management, Aetna insurance, and our home healthcare delivery. It's a very large, very complex, very mission-critical infrastructure and a footprint. I joined CVS Health about 3 years ago with a clear mandate to build a world-class engineering organization, build a culture of high trust and high performance. The way we did this was we invested heavily in talent, we set engineering standards, and execution discipline. Those foundations enabled us to build the transformation journey that we're on today.
Very good to hear. Lenny, you're on this AI journey.
Yes.
And could you please tell me a little bit more about the AI journey that you're on and how long have you been and what were your goals?
Sure. So one of the biggest lessons that we've learned so far, and if you were able to catch G2's keynote, he touched on a lot of the issues. You and Ragesh touched on many of the issues in your opening monologue.
Yep.
But basically, the real value of AI doesn't only come from the models that you build, but it also comes from enabling the models to run on the infrastructure reliably, securely, and at scale.
Yep.
And that fundamentally is an infrastructure challenge. One of the things we've learned, AI workloads behave very, very differently than traditional enterprise applications. If the network can't keep up, performance drops very, very quickly. Mm-hmm. And in many environments, the real bottleneck is not compute, but rather it's the data movement that you're seeing back and forth at the rapid speeds. So in order to accommodate this, we had to rethink and reimagine how we build our networks. So we re-architected our networks for low latency, high throughput, scale, to be able to scale at speed, and shifting that thought process and that mentality was central to how we design our networks today.
Awesome. So it looks like you got the technical thing figured out.
Yes.
But we do not have infinite resources to manage all these complex networks. So
Correct.
from a staffing and skill set perspective, how are you handling that?
Sure. So one of the things that we had to think about, and again, G2 touched upon this, was we had to rethink our data center strategy and how we look at data centers. When we started to deploy our AI workloads, we quickly figured out that as we scale up and we scale out, we didn't have the power in our traditional data centers to be able to handle that kind of throughput, that kind of power, and be able to scale up and scale out efficiently. So what we had to do is we took the approach of, instead of looking at a few traditional data centers that we had, we decided to standardize on co-location facilities. So we are deploying these co-location facilities across the west, the central, and the east part of the United States. So the objective for us was straightforward and it was clear. Place the information closer to the workloads and the users. That reduces latency, improves your efficiency, and stabilizes your performance without creating the network choke points.
Okay. Outstanding. Now,
The World of Solutions Happy
how?
Hour will be starting in 15 minutes in Hall 1.
All right. How does that translate to business benefits and customer outcomes, Lenny, from CVS Health point of view?
Sure. So if you design networks long enough, you will clearly understand that technology only matters if it delivers real outcomes. Okay? And for us and the business, those outcomes translate to speed, reliability, security, and scalability. Right? When the network is designed for ultra-low latency, high throughput, and data movement, you're able to deploy AI workloads quickly and at scale. So for the customers, this is a tangible benefit for our customers. It allows us to keep the networks on, always up, always performing, and always operating fast. So the best infrastructure for the customer is one that they don't have to think about.
Okay, excellent. So thank you for sharing what you have done so far. And as you look ahead for the next 3 to 5 years, what are the trends that you're seeing from AI perspective? And this is also my last question. So any last words you would like to share with the audience here?
Sure. So as I look ahead 3 to 5 years, there are 3 major trends that are beginning to stand out to me. The first thing is scale by design. Anchoring back to what I said earlier, AI traffic patterns are not going to be predictable, and they are not going to be gradual. They are going to be very bursty, and they are going to scale quickly, very quickly. And if the network can't keep up, performance degrades fast. So one of the things that you have to start to think about is how is automation going to help you achieve that scale up and scale out? Automation becomes a critical point, and it becomes the control plane. So humans cannot be in the critical path. Otherwise, you will not be able to scale at the speed that you need to scale up and scale out at. So that's absolutely critical. Which brings me to my third point, and that's trust and reliability at the network layer. As AI begins to embed itself into clinical, retail, and customer workloads, the network becomes a trusted part of that model. And if I could leave you with really one final thought.
Yep.
AI doesn't fail because of a lack of models, a lack of guardrails, or a lack of security. It also can fail because the infrastructure can't keep up. The companies that are going to win at AI are going to treat the network as a strategic enabler. So not treating the network as a utility or an afterthought is fundamentally critical to how you think about building these infrastructures. If you build the foundation right and you innovate and accelerate safely, you will be able to deploy these safely, reliably, and at scale.
Very well. Thank you, Lenny. Thank you for sharing your AI journey, and big round of applause for Lenny, please.
Thank you.
And we wish you good luck in the next phase of your AI journey.
Thank you so much.
Thanks a lot.
Thank you.
Okay. So that concludes our presentation. If you have any questions, so I, Rakesh, and Lenny are standing by. So please come talk to us if you have any questions. Thank you.